Now if you hit a wall, do you feel the pain on your fingers? You do, right? Even when we hit water with certain amount of force, we feel the pain on our palms. Now, this is what Newton explains in his third law of motion. Let us see, why do we feel hurt? Now, let us say we have rocket in front of us. We know that the gases of rockets exert certain amount of pressure or force on the earth, on the ground. And that force is called as the action force. Now, when this action force is given by the rocket or the gases of the rockets, an equal amount of reaction force is given by the earth or the ground. And this is why what happens is this rocket is actually propelled in the upward direction. Now, there were two objects over here. One was rocket and the other was earth, right? Action force was given by the rocket and reaction force was given by the floor or the earth or the ground, we can say. That means here we have two objects and two different objects are exerting force, and that is the reason we can see that there was motion. If we give these two forces, that is equal forces in opposite directions, on the same body, then no motion will take place. So what does Newton's third law of motion say? It says every action force has an equal and opposite reaction force which acts simultaneously. Now, this is the reason when we actually hit a wall, an equal amount of reaction force is given by the wall on our fingers, and that is the reason we feel pain. So what does third law of motion imply? It has to say certain amount of things. First is that action and reaction are the terms which will express the force. So we say action force and a reaction force. Now secondly, it says that the forces act in pairs. One force cannot exist by itself. If I just punch in the air, doesn't make a difference. But if I punch on somebody's face, it will actually do some damage, right? Now next point, it says action and reaction forces act simultaneously. This is a very simple point. And finally, action and reaction forces act on different objects. They do not act on the same object, and hence they do not cancel each other, and that is the reason we can see motion of the object. So this was Newton's third law of motion. Now let us move on to something very interesting, and this is called as law of conservation of momentum. So let us see the statement of law of conservation of momentum. The statement says when two bodies collide, the total momentum before collision is equal to the total momentum after collision. How do we understand this? We understand this with the help of a mathematical formula. So let's derive that mathematical formula. So let us assume that this object or this car is object number 1 and this car is object number 2. So all the parameters of this car will be 1. That is, its mass will be m1, its initial velocity will be u1, its final velocity will be v1, and similarly m2, u2 and v2, right? Now let us assume, let us say that they both start moving, and when they are moving, obviously they will move with certain amount of velocity, and this velocity is called as initial velocity. Now since this is object number 1, its initial velocity will be u1 and its initial velocity will be u2, right? So this is the initial velocity before collision. Now its mass was m1, its mass was m2. So its momentum becomes m1 into u1, and this car's momentum becomes m2 into u2. When we add them, this becomes m1 u1 plus m2 u2, which is nothing but the total momentum before collision. That is the total momentum of both these cars, right? So this was before collision. Now let us assume that they both collide, and after colliding they are set into motion and their velocities will change, right? So now the velocity will be final velocity. So this car has the final velocity v1 and this car has a final velocity v2. Now the momentum changes. Now this car's momentum becomes m1 v1, right? And this car's momentum becomes m2 v2. Again when we add them, now it becomes m1 v1 plus m2 v2, which is nothing but the total momentum after collision. So m1 v1 plus m2 v2 is the total momentum after collision. Now what we should understand is both will exert equal amount of force on the other, right? Because Newton's third law of motion says every action force has an equal and opposite reaction force. Let us assume that the force exerted by the first car on the second car is F1 and by the second car on the first car is F2. We know F1 will be equal to F2, but the direction is opposite. That means we need to add a minus sign. So what do we actually understand over here is we can write the equation as F1 is equal to minus F2. Why minus? Because the direction is opposite. Now let's come here. We know the formula of force, right? Force is equal to m into A. So F1 will be equal to m1 into A1, which will be equal to minus, we have F2, right? So it becomes m2 into A2. Now we'll keep m1 as it is. You see, m1 is as it is. But we know we have a formula for acceleration, that is v minus u upon t. So instead of A1, we'll write v1 minus u1 upon t. Now why don't we write t1? Because we know that the forces act simultaneously. That means the time of collision for both of them is nothing but the same. That means t1 is equal to t2. Now minus m2 remains as it is. So instead of A2, what we'll write over here is v2 minus u2 upon t again. Now t and t gets cancelled. So we'll just write the numerator as it is, right? So we are writing the numerator as it is over here. If you compare this and this, we know that the numerators are same. Now we'll open the bracket. Now see on the left hand side over here, m1 into v1 becomes m1 v1. This minus sign remains as it is, and m1 into u1 becomes m1 u1. Then we write is equal to minus m2 into v2 becomes minus m2 v2. Minus into minus becomes plus m2 into u2. Now we have minus m1 u1 over here and minus m2 v2 over here. We'll shift both the minuses on the either sides. That means m1 v1 remains as it is, but this m2 v2 goes over there, becomes plus m2 v2. You see, this is very simple. This might look big, but it is actually very simple. Now we write m2 u2 over here and m1 u1 we bring over here. So we write m1 u1, which is nothing but this m1 u1, and this m2 u2 remains as it is. Now see, we have m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. Now we know that if A is equal to B, then B is equal to A. Similarly, this entire term will be equal to that entire term. So what we'll do right now is we'll shift this side over that side and we'll bring that side this side. So what do we get? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now remember, m1 u1 plus m2 u2 was nothing but the total momentum before collision, and m1 v1 plus m2 v2 was nothing but total momentum after collision. So with this equation, what do we actually understand? We understand that the total momentum before collision is equal to the total momentum after collision. So this is how we prove the law of conservation of momentum, which says when two bodies collide, the total momentum before collision is equal to the total momentum after collision.